Okay, so first up with this problem. Yes, I know oxygen is spelled incorrectly. Right? Nobody knows that. Actually, this packet, as you can tell, is pretty old, right? I haven't noticed it in 10 years. This is the first time I noticed it. It's probably because I'm filming. I'm, making sure everything's right. But there you go. Don't thumb this down this. All right. Okay. So what is that? What you do, right? You like, dislike. Yeah. All right. Let's start this over. All right. So what do we do first?
Read the problem.
Yeah, okay. Let's say that we read the problem, we went over that it's spelled wrong. What else do we do? Exactly. We need to convert both of the givens into what? Well, no, I know, but I mean like later on. Like what's the goal of converting them into what?
Moles of the product.
Yeah, we're going to convert them eventually into grams of the product, right? We're going to go all the way to grams of the product. Now, here's an interesting problem, too, because they're giving you 10 grams of each of them, right? So right off the bat, you can't just assume, oh, maybe the smaller number is the one that's going to run out first, right? You should never just assume that the smaller number is the one that's going to run out first. And in this problem, we can't because they're both the same. So let's go through this. Aluminum is what, 26.988? Oh, no. Grams of aluminum. This one's going to have a lot of bloopers on it. What about on the top? 1 mole. All right, good. And on the bottom? Good, 4 moles of aluminum. Oh, boy. And then on the top? Good. Okay, and then what's the molecular mass of this aluminum oxide thing? 100 what? Wait, what?
96.
That's a decimal. Oh, man. Let's try the other pen.
It's coming down.
Yeah, this is not good. Hopefully this is not the first video you're watching. The quality is usually much better. Marginally better. Marginally better. Okay, so we've done all of that. When we get our answer, what do we get? Well, I think it was the pen. Okay, so we have this, and now what do we do?
The other one.
Yeah, the same thing, but for the other, which is also 10 grams. So 10.0 grams of oxygen. 32 grams is the molecular mass. 1 mole is up here. How many moles on the bottom for oxygen? 3, good. All right, and what about on the top? 2, yep. And once you get to here, the rest of the problem is going to be the same as over here, all right? Because we're doing the same thing. Okay, what'd you guys get for this one? 21.2? Yeah, you sure that's right?
Yes.
It's going on the internet, so everything's true on the internet, right? So it's going to be right. All right, so what do we do next?
Convert the limiting reactant to excess.
Good, so we need to identify the limiting reactant, right? Which one's the limiting reactant?
Aluminum.
Yeah, how do you know it's aluminum? There's less, yeah, that's made. And what do we know about these two numbers? Yeah, this is the product produced, good. All right, that's the product produced. And then over here we have, yeah, we can't make this because we're going to run out of the aluminum first, so we can't make that much aluminum oxide. Okay, so we know the product produced, we know the limiting reactant. What's this going to be? Yeah, this is the excess reactant. Good. All right, now what's the next conversion we have to do? we start with? Good, yeah, 10 grams of aluminum. We start with the limiting reactant, and then we're going to convert this eventually all the way into what? Yeah, the excess, right? The excess. Okay, so let's do this. And you don't have to look at the periodic table because you know the molecular mass of all this stuff because you wrote it up here somewhere. So first we're going from grams to moles. All right, then we're going to do the mole switch. There's 4 moles of aluminum. All right, on the top, what are we going to again? Good, oxygen, all right. There's 3 moles of oxygen. And then we want to go to grams of oxygen, so 1 mole oxygen, and then 32.00 grams of oxygen. Why did we go to grams of oxygen instead of like liters of oxygen? It's a good question, right? You could. Oxygen's a gas.
It asks for grams.
It asks for grams, good. And then we need to do a subtraction, right? Is this in liters? No, it's in grams, right? So you're going to convert this into the same unit so you can subtract, right? If that was in liters, though, then you would have to convert it into liters. Does that make sense? So it does matter what they give you for what you kind of come up with here. Okay, and what'd you guys get for an answer here? 8.90? And what does this mean, 8.90? Yeah, this is the excess used. Okay, so then what do we do? Yeah, so this is the excess given, and then the excess used would be 8.90 grams. That's used. And when you subtract them, you get 1.1 grams of oxygen left over. And then sig figs for this, because you're subtracting, you just go with the least number of decimal places. So that's why it's just 1.1. It looks like it has less sig figs. It does, but that's the correct way to do subtraction. All right? Any questions with any of that? Did we answer all the questions? Yeah, everything that we've learned so far, right? Yeah, James.
Wait, so why is it 2 sig figs?
Oh, okay, so when you subtract, you see how the 10 has 1 decimal place?
Yeah.
And then the 8.90 has 2 decimal places? When you subtract, you go with the least number of decimal places. So we would round 1.1 to 1.1 instead of saying it's 1.10. That's all. All right? Any others?